Hey, this is James Howard going through program assignment 3. I'm going to walk you through the code and show you the demo of what I've built. Um, I got through the Q learning. I did not actually get to the epsilon greedy, so that will not be shown here. Um, I decided to create a website for this so that it would have a graphical user interface, and I used a React app to do so. So we can just start over here on the left. Um, all these files are just configuration files. This HTML index.html is the main file, and it imports source/main.tsx, which is right here. All that does is spin up the app component, which is right here, and then the app component sets up a route for each of the different components that I created, and it's the default path opens the menu, which is what you see over here on the right. These are just style sheets for making it look pretty. Then if we look at the menu, it's just very simple. It has a title and then links, buttons to the 3 different grid world demos. The grid world file, creates an interface this is for each cell inside the grid. I'll go ahead and pull up the value iteration so you can see what the grid looks like. So each grid cell has these properties: its row, its column, its current value, its current direction. This is the direction that the arrow will be pointing on the cell. Whether or not it's a wall, whether or not it's an exit value, whether or not we should show the Q values, the quadrants, and then these are each of the Q values. Down here we just have some functions for rendering the arrow on the cells and for coloring the background of the cells according to the value of that particular cell. And then this is the function for rendering the quadrants so that you can see the Q values when you hit the Show Quadrants button over here. Then you can see down here, this is for rendering the agent when we get to the Q learning. It's just a blue dot that you can move around the grid world. And then this is the container that will be on each page, each module. So then if we go to, we'll start with value iteration, and these are all going to be fairly similar. We start with the grid initialized up here, setting everything to 0, directions to null, setting the exit value for the top right cell to 1 and the next one down to -1. These are all React functions that you use to maintain and set state. If we start down here, when you click Run Value Iteration, that's when this function gets called. It looks at the number of iterations from this box, and it'll run that many iterations. So if we click it once, it runs 1 iteration. If we click it again and again and again, or you can set it to 10, and then it will run 10 total iterations. When we reset the grid, it sets everything else back to 0. So anyway, it's going through the number of iterations that you set. It creates a clone of the grid that's being displayed, and then it walks through each cell in the grid, and if the cell is not a wall, then it goes to this set cell value, and this is where the meat of the work takes place. We get the current cell. We say if it's an exit, then its value is the exit value, which is going to be 1 or -1, and then we return. Then we walk through each of the directions represented by each of the Q values, and we call this first we reset the Q value for each Q value. We set the value to 0 just to initialize it. Then we call this get directions function, which basically says, based on the direction, what are the 3 possible directions that you could move. So for example, if you wanted to go north, if your direction was north, then we return west, north, and east. And then once we get those directions, we say for each of those, we get what the next cell would be, which is this function down here. And just to show you what it does, it's you pass in the direction. It says, okay, for instance, if your direction was north, you say, okay, are we at the top of the grid? If row is greater than, as long as row is greater than 0, then the next cell is going to be your grid, your cell at row -1 in column. And then if that cell is a wall, then just return the cell that you're already at. Otherwise, return the next cell. And if your row is not greater than 0, then we're also going to return the current cell. And so we do those for each of the directions. We get the next cell, and then we set this discounted value equal to the next cell's dot value times the discount that we set in this drop down right here, plus the reward, which we set in this drop down right here. And then then we say we set the Q values equal to the if the direction for the we walk through each of the Q values, and if the Q value that you're looking at is the same direction as the direction you have from down here, meaning the direction you intended to go, then you set that Q value equal to your noise factor divided by 100, 1 minus that, times the discounted value. Otherwise, noise factor divided by 200 times discounted value. So this is going to be, if your noise factor is 20, then in this case this would be 80% times the discounted value, and this would be 10% times the discounted value. So you add those up, and then for setting the value of the cell itself, we look at all the Q values that we just set, and we get the maximum of that and the corresponding direction using this reduce function, and then we set the cell's value to that max value and set the cell's direction to that direction. And so as you can see, set this back to 1. So we run value iteration. We can show the quadrants, show what the Q values are as they change. And then if we hide the quadrants, you can see that like this will take the highest Q value as 0.84, 0.72, 0.51. So that's it for value iteration. Looks like it takes about 15 iterations to converge to one value for each grid cell. Okay, going back to the menu, we can now look at policy iteration, and we'll look at policy iteration over here. Similar, except for now when we run policy iteration, we're going to, so we have loops within loops here, because we run policy evaluation a certain number of times, and then for each of those certain number of times we run one policy extraction. So if we look back over here, we could, if we set this to 10 and overall iterations to 1, we're going to run 10 policy evaluations and then 1 policy extraction. And that gets us to there, and then if we do it again, we've pretty much converged, I believe. So anyway, so we're looking at overall iterations, which is this number right here, and for each one of those, we're going to run our policy iterations first. Which walks through the grid again, each cell. And as long as you're not a cell, if you're a wall or an exit, then we just continue. Oh, I'm sorry, this is policy extraction. We'll run policy evaluations first. Which is saying for each iteration, which is the number that we set over here, evaluation iterations, just copy the displayed grid, and then for each cell in the grid, as long as the cell is not a wall, we call this set cell value, which is going to be similar to value iteration, except for in this case we're not doing it for each Q value, each possible direction. We're only doing it for the direction that it's first set in. And I forgot to show you at the top, we initialize all the directions for each cell to north. So going back down to set cell value, we get the possible directions for whatever the current direction is of the cell, and again that's going to be your, if you're north, then you return west, northeast, etc., etc. And then for each of those directions we get the next cell. Again, that's the exact same code as in the value iteration. And then we get the discounted value, which is going to be the next cell's value times the discount plus the reward, which is set here. Here's the discount set here. And then again, we're saying take the noise factor into account and say if the direction that is the current direction is the intended direction, then we're going to say noise factor divided by 100, 1 minus that, times the discounted value, otherwise noise factor divided by 200 times the discounted value. After we run all of our policy evaluations that for whatever number we set here, then we call policy extraction. And then in policy extraction, we're going through each of the grid cells, and if it's not a wall and it's not an exit, we keep going. We get the Q value keys for each grid cell, which is going to be the north, south, east, and west. And then for each of those, we should reset them to 0, and then we get the directions again. And then for each of those directions, we get the next cell, and then we set the discounted value equal to that sales value times the discount plus a reward, and then we say we set the Q value for that direction, again according to our formula there, taking the noise factor into account. And then that's how we set all our Q values, and then we use this reduce function again to figure out what the maximum Q value is, and we set the cell's direction equal to the direction corresponding to the maximum Q value for each cell. So if we go back over here and reset, you can see that they're all defaulting to north. We can show the quadrants. If we run policy iteration, let's say we run evaluation 10 times, and then with one extraction we come up with that. And if we do it again, come up with that. Alright, and so then finally looking at Q learning, go back to the menu. In this one we have user input, so I can use the arrow keys to move this blue circle around, and as you can see it updates Q values as we progress. We have the ability to set the learning rate, the discount factor, and the reward up here. And the way this guy works is we have a key handler here that basically listens for user input from the keyboard. First thing it does is say, hey, if you're not arrow up, arrow down, arrow left, or arrow right, then just exit. Then we clone the viewable grid again, so we're not altering it directly. We get the direction from the arrows that was pressed, and then we convert that direction into an ordinal direction, north, south, east, or west. Basically just up is north, down is south, etc., etc. We get the current cell that the agent is at, and we say, hey, if the cell's an exit, then your next row is going to be 2, your next column is going to be 0, which means it starts back here, back down here at the bottom left. And then also if you're an exit, then your sample value is just going to be the exit value of that cell, and so then you set the current cell value equals to 1 minus the learning rate times the current cell value plus the learning rate times sample. So this is the running average. If you're not an exit cell, then we get the current Q value corresponding to the direction that was pushed for that cell. We get the next cell using this familiar function. And then from that next cell we say, okay, that our max Q value is going to be, if the next cell is an exit cell, then that's just the exit value, or the value of the cell rather. Otherwise it's going to be the max of the Q values of that cell. And so then we set the sample equal to the reward, which defaults to 0, but you can set it to whatever you want. plus the discount factor currently set to 0.9 times that max Q value that you got. Then we just set the Q value of the current cell that corresponds to the direction that was pressed, equal to, again, the 1 minus learning rate times the Q value plus learning rate times the sample, the running average formula here, and then we set our next row and our next column, and then we just update the grid and set the agent to a new position, and we update the iterations, which is shown down here at the bottom. That's pretty much the meat of the code. Thank you.